And Julia, pass out to you, dear. Yes, eventually. Let me eat my life again. I'm recording and don't even have my life together. That's what's funny. Okay.
Miss Thompson, did you know that Owen is moving?
Yay. I mean, I don't even know what to say. Okay. I'm sorry. Okay. Now that we've done 50 seconds unproductive for YouTube, let's actually be productive now. First things first, let's go over the bell ringer answers. If you want to have colors out for your notes, you can. It is kind of a colorful day. Does someone have an answer to the first question on the bell ringer?
I said no.
No?
Yeah, because she'll need, she'll have to work like 6 hours to get that $40.
Okay, can someone give me some math to back up his answer? Yes.
There's a formula I use for it plus 30.
And it needs to equal 40 because she needs at least $40. So 4H equals 30. So H equals 30 over 4. What decimal do you get for that? 30 over, yes, dear. So it's got to be greater than or equal to. She needs at least $40. Thank you, dear. Because she needs at least $40. Good, thank you, Trey. What's 30 over 4? I know that's 15 over 2. Is that 7.5? Okay, so she's going to have to work at least 7.5 hours. So if she only babysits 5, no, she's not able to get her TV. That's fine. I'm sure what you did was awesome, but Trey is right. It specifically says in the problem, write an inequality for this situation. So we were supposed to do that. I didn't pay attention to it either. So Trey's right. This is what we were supposed to do. Are there other ways to solve? Of course, but the directions said to do this. Oh my goodness. Okay, and then what is the answer to the second one? D. What did you use to solve? Okay. If I use elimination, and I need to say this because there is one person in the room who is still confused on elimination. If I'm using elimination, yes, they have to have the same number in front of the variable, so they both have a 3. What's the issue? They're both positive, so one's got to be positive and one's got to be negative in order for them to cancel out. So I'm going to multiply. It doesn't matter what line. I'm going to pick on the top one. It doesn't matter. So I have negative 3x plus 8y equals positive 50. 3x minus 5y equals negative 38. I get 3y equals 22. 12. I can't add today. So y equals 4. Okay, and then I do have some systems tests I need to give back to people that finally finished it last week. And there's one person who can do all this. They get to here, and then they stop. They stop. Why would you stop? What kind of answer do I need? I need an ordered pair. So if you don't plug it in and solve for x, you've still not quite finished the problem. So you can pick either equation. I'm going to pick the bottom one for kicks and giggles. So 3x minus 5 times 4 equals negative 38. So 3x minus 20 equals negative 38. 3x equals negative 18. X equals negative 6. I get you're super smart. But just because you got what y equals doesn't mean you're done. We need an ordered pair. So it's negative 6, 4. Now I say all that. And technically I'm wrong in this specific situation. Why is my argument invalid in this specific situation? Why does, and I'm picking on Gavin, why does Gavin not have to plug it in and solve for x in this specific problem?
Because in the answer choices, it's only like one answer that has 4 as a lot.
Yes! Okay, so Shanti's on to what I'm saying. Once you get y equals 4, that's the only one with a y value of 4. So do you actually have to plug it in and solve for x? In that case, no. In normal problems, yes. Okay, are there any questions about this bell ringer? Then I want to go over the big sheet first, not the tiny sheet. I want the big sheet. Where is that big sheet? So many. I know you gave me one, Julia. I just don't know what I did with it. Just don't know what I did with it.
Somebody wrote 2.1. Somebody wrote it in my folder.
Where did you put mine, Julia? Under my thingy. Bless you. I'll make a copy before I lose it forever.
Too many checks on the wall.
Okay, so this seems completely random. What were we talking about last week? What were the minions on? Exponents. So it seems what we doing today, I mean, the learning target says something about rational, I can simplify rational exponents. That sounds okay. But then when you look down at the sheet in your hands, you're like, this is not an exponent. I don't know what this is. This is definitely not an exponent now. So, we're actually going to talk about something called a radical today. And it has different parts. Now, last week I get your geniuses, and you already knew it was called a base and an exponent. I got that. I know. But I bet a lot of these vocab terms you don't already know. So this is what you would need to make sure you knew by tomorrow. Like, this is what we need to fix. You need to know the following vocab words. This symbol, this little black thing, looks like a house. We call it the radical symbol. We call this black-looking checkmark house thing, we call it the radical symbol. The radical symbol. And so the entire thing, including whatever's written under it, for instance, 24 could be written under it. 128n to the 8th. Lots of different things could go under it, under the radical symbol. But the entire thing is called a radical. So the entire thing is called a radical. Now it might have a number here, and it might have a number under the radical symbol. Or, like you can see over here on the side, it might have variables raised to various exponents. It could have lots of different things. It doesn't necessarily just have to be a number like 125. But for me, I'm going to do 125. Okay, so this tiny number, the 3, or if you look over here, I see a 4, a 6, etc. That tiny number is called the index. So far for sure, you've got to know what a radical is. And you have to remember what an index is. And the last one I'm going to star is this one. But it's the easiest to remember because what's under the radical is called the radicand. So what's under the radical is called the radicand. So let's say it all again. There's this weird looking house symbol. It's called the radical symbol. There's this weird looking house symbol. It's called the radical symbol. Everything, including the house symbol, is called the radical. The tiny number out front, see how it's written above the little house here? That's called the index. And then whatever's underneath the radical symbol, underneath the house, is called the radicand. You've got to know these vocab terms in order to answer the questions. So that's, if there was homework tonight, it would be make sure you know those vocab terms. I get you knew base and exponent. You don't know these. They're new. We've got to learn these. Okay, so I'm going to give you and your group of, oh, I need to fill in that last line. Need to fill in that last line. It'd be the most important. Okay. You know how we keep talking about how things are understood? Like there's an understood 1 exponent? Well, there's an understood thing in front. There's an understood index here on 24. What would you say out loud? What does this problem say, that first one? What would you say before you heard words like radical? What would you say? Square root. So what number should I put for the index then? 2. If they don't write it, it's an understood 2. If they don't write the index number. So if the index is not written, it is automatically a 2. If the index is not written, it's automatically a 2. So square root of 24. It's automatically a 2. Okay, I'm going to give you and your group about 3 minutes, if that, to go ahead and do all the problems so we don't have to have any homework. I need to know the index and the radicand. I'm going to get each group to share some of their answers in just a second. Let's see. I want to hear from, I'm going to do the random ones too. Let's do Owen's group. What is the answer to this one? Look where my finger is. What is the index?
The index is 30.
And what was the radicand? Okay. I knew you could totally handle this. Okay, Julia's group, what is the answer to this one? I'm going to do I for index. And then what's the radicand? 16xy. Okay, Jorgen's group, what is the answer to this one? Why do I keep picking all the 3s? I'm picking a different one, Jorgen. I want this one. Okay, and then Jameson's group, let's do the long one.
X is 6, and the radical is 148, X is 7, Y is 7.
Okay, and then Trey's group, when Trey can keep it together, what is the answer to? I guess the second one.
Oh, the index is 4.
Okay, I knew you could handle this. This is just a vocab term thing. Are there any questions about parts of a radical? You need to know parts of a radical in order to be successful in this section. So it's not only enough that you got exponents on all those rules. Now you got to get this too, and eventually they'll all be on a test together. Okay, take out this thing so we can see how they're correlated. Again, your first question today should have been Miss Compton. I thought we were talking about exponents. Where did this come from then? Like this radical and everything. I don't understand how that's tied to an exponent, which is what the tiny handout's going to help us clear up. They're actually highly correlated, meaning they go together. So there's a reason we're doing them at the same time.
Are they a couple?
No. It's like my evil twin.
Oh.
We all have one.
My evil twin. Okay, what goes here? What goes there? The index. So I'm going to put I for index. I'll write the word index if that helps. So I for index. Okay, and then what would we put for this? What is that called? It is called an exponent. What's the other word we did for exponent?
Power.
Power, but I won't exponent. But yes, I'm just making sure we're still on the same page. E for exponent. I'm going to use actual problem numbers in a second. I'm just proving a point right now that it works for any of them. Okay, so this we understand is radical form. What we don't know is something called rational exponent form. That's like, what is that? Rational exponent form. But the word rational, all that's going to mean is that we are cool with, for once in our life, we're cool with having fractions in the exponent. So what's crazy is we hate on poor negatives. They can't be in the exponent. But it's okay if you have a fraction in the exponent. So let me say that again because I feel like this is unkind. Can't have a negative exponent, but we're okay with a fraction exponent. I don't know why people hate on negatives, but they do. So it's okay if we have fractions in the exponent. In fact, we're going to take the index and the exponent, and we're going to rewrite them over here so we can see how we can go from radical to rational. Okay, so if you take your I and you move it to the denominator, and you take your E and you move it to the numerator, you have rewritten your problem from radical to rational. Which, why would we even want to do that? So we need to look at some examples in just a second. Okay, first, before we talk about why you would want to do that, let's work a problem with it. So if I give you 3x to the 7th, obviously that's radical. If I want to change it to rational, what would I write? Let me zoom in for my people in the back. I have 3 and then, so I would say x to the 7/3 or 7 over 3. Notice this number went in the numerator, this number went in the denominator. This number went in the numerator, that number went in the denominator. Maddie, that's all I can do.
I know, I can barely see them.
That's all I can do. Okay, so let's rewrite our original problem today. Our original problem today was on that other sheet. We wrote something 125. I think we did cube root of 125. So a 3 and a 125, and that is super ugly. Let me write it prettier. 3 cube root 125. So I want to know the cube root of 125. How would I rewrite that from radical into rational?
125 over 130.
Say it again.
125.
Raised to the what?
130.
He is correct, because the exponent is an understood 1. So that goes in the numerator, that goes in the denominator, 125 to the 1/3. Are there any questions about how we're changing it? Besides why are we doing it? Are there any questions about how we're doing it? Everyone could do it themselves if we had another page full of it. Okay, I need my calculator. Let's see, Trey, give me yours. Okay, let's talk about why we would want to do this. Why, and it seems crazy, but why this is more useful than this. Okay, so if I have my calculator, and I'm wanting to do, let's say, cube root of 125, you have to press the index number first. Then you have to press the second symbol, and it's in blue. It's right above the one that looks like an arrow. So I got to press 3, second button, and then that weird looking thing. So now my screen has this. So again, I press the number 3, then I press second, that weird looking house, the radical, good gravy, radican's the stuff under it, the radical symbol. And then I press 125 and I press enter, and it tells me the answer is 5. That's kind of hard to remember to press the index button first before pressing the second and the radical symbol. That's really complicated. Most people don't do that. In fact, a lot of calculators don't even have that button on it. This is what people would do instead. It'd be much easier to do 125 raised to the 1/3. So 125, Then you press the little arrow symbol, because that's the exponent symbol. That lets them know you're going into the exponent. And then since we want 1/3, we're going to put it in parentheses, 1/3. And we've got the answer. So if I needed to know 8 to the 1/3, I would do 8 and raise 2 and then put 1/3 in parentheses. It's easy. I know fraction exponents sound complicated, but your calculator can do them so easy as long as you put the fraction in parentheses. And it's going to be so much faster and easier for you, in my mind, in rational form. But I like calculators. Jameson, you had a question. If you don't put it in parentheses, it's an order of operations thing, right? Your calculator doesn't see your paper. So if you don't put the fraction in parentheses, it thinks you're raising 8 to the 1 first, and then dividing the whole thing by 3. So it's going to tell you 8/3 or whatever that decimal equivalent is. Because your calculator doesn't have your eyes, so it doesn't understand that 1/3 is both in the exponent. That's why I put it in parentheses, because they're both in the exponent. Yes, dear? You shouldn't. It should be an issue. It might work on mine. Are you using one of mine? What are you using? Show me your calculator. It might work on mine, so she didn't put it in parentheses in mine, and it might work on my tiny little blue ones. But again, our goal is to get to my giant yellow ones that can super graph and everything. And they're sophisticated, and you will have to put it in fraction on them. So might as well get in good calculator habits of putting things in parentheses. Yes, dear? Did you put it in the yellow one? Yeah, that's what I'm telling you. It's because it's not a graphing calculator. Graphing calculators are special, and they're going to need a little more talking to. If I were you, I always put fractions in parentheses, just in case. I want the calculator to know exactly what I see on my paper. Otherwise, you might confuse it. We talked the other day about how if you tell your calculator -2 raised to the 3rd, it'll give you -8. But what if you had meant -2 raised to the 4th? I shouldn't have done 3rd. I need to do 4th. If I do -2 raised to the 4th, it gives you -16. What if you were supposed to put that -2 in parentheses? What if it was -2 raised to the 4th? Then it gives you +16. So it matters how you type things in your calculator. And they might give you a sign change. It might give you +16 when you're supposed to get negative or vice versa.
Be
careful with your calculator. Then, like this, 2 raised to the 4th, you get a -16.
I'm talking about like the power is outside of the parentheses too, and it's just a 2.
Power is outside the parentheses too, and it's just a 2.
Like the only thing in the parentheses is 2.
Now what? It'll tell you -2.
I'm talking about.
I don't know what you're talking.
I'm talking about raised to the 4th power.
Oh. It'll give me -16. Okay. Then got confused. That's all I had to say about that. Surely you have something for me to work on, or good for you, you've actually done all you were supposed to do, so you have a few minutes apiece.